Hey, Jeannie.
Yeah, Brew.
Who's our guest on the Energy Nerd Show today?
Today we have Ida Weiss, who's an associate at Synapse. Good morning, Ida.
Good to see you, Ida.
Thanks for having me here.
Yeah, thanks for being here. It's really nice to be here with you and hear a little bit more about what you've been working on. So what are we going to talk about today?
Yeah, so today I thought we could talk about two things. One is some recent work we did for the city and county of Denver to look at building electrification. And the other is some recent work we did for Massachusetts EEA to look at EVs and transportation electrification.
Both sound cool.
So are we going to see maps?
You're going to see some maps.
Okay.
You're going to see a lot of maps. Maps are my favorite. I do a lot of GIS, and I think maps are the best way to communicate a story. So yeah, you'll see some of those.
Awesome.
Where should we start?
Well, let's start at Denver because I have that pulled up on my screen. So you might recall from a few weeks ago, I talked about this at one of our business lunches, but we did a pretty cool project for the city and county of Denver. They wanted to know basically if every single building in the city electrifies, what will be the peak load impacts? What will be the impacts to their system? And so this was kind of a unique analysis, I think, because we did this like bottom-up method where we looked at every single building and estimated its energy footprint. And I think a lot of these analyses tend to use more like top-down methods where they say, okay, for a given region, what do we expect the future load to be? Now let's allocate that to different areas. So we took this bottom-up method and we started off with a database of buildings in Denver that we got from their tax office. And then we estimated these energy intensity factors for different types of electrification. So like heating, hot water heating, and other things like appliances. And then we basically estimated the load at every single building in Denver and put it on a map and summed it up and saw what the future peak loads could be in Denver. And the other part of this analysis was trying to figure out how energy efficiency could reduce that future winter peak load. And so that was a pretty cool part. And we basically looked at a couple different things. We said, what if Denver's downtown uses a geothermal network loop? What if there's some really aggressive energy efficiency measures that buildings can use? And how would that impact future peak loads?
Cool.
Yeah. So can you show us?
I definitely can show you, yeah.
And
enough talking.
While we're kind of going to the maps, I'm curious if we could pause and talk about the data, because you said Denver had data on every building in the city, county. What kind of data did they have? I mean, and then you had to use more data than just what they had.
Right.
Okay.
Yeah, totally. So Denver has an office that is the tax office, basically. And they're charged with evaluating basically the monetary value of every single, assessing the value of every single building in Denver for tax reasons. And so their main focus is not to gather data on building footprint, building area, but it's kind of one of the side things that they use in their assessment of building value. So they have some nice spreadsheets on every single building in Denver, residential and commercial, all these different data fields, and one of them is building area, or roughly building area. It's not quite, and we had to do a little bit of QC and rejiggering of the numbers in the fields that they had to kind of get out this field that was super duper important for our analysis.
Cool.
Yeah.
And every city will have that, every big city, because they're charging property taxes and they often base it on footprint or floor area they collect that.
Yeah, they should.
Yeah.
They should have it. We were recently working on a proposal for another project actually doing almost the same exact work. And when I was trying to figure out, do they have this data set available, they sort of did, but it was locked away where you could really only click on individual properties and get that data out.
Oh.
So that would have been challenging for us because we would have, if we win that project, we'll need to ask them to go into the back end of their database and get this data out, which is not always a given that they can do that or that they will easily.
Yeah, no, I love looking at assessors' databases in different places, but that's the only part I've ever seen was a particular building. You have to search for it. So I think it's great that Denver had Was it publicly available
It
in
was.
Denver? You just went right to it. Okay.
Yeah, it was
That's
publicly it was publicly available. It was great. The quality, there were definitely some things about the data that we called up the assessor's office and asked them about a few times. We said, "Hey, this building doesn't look 4.5 million square feet on the map. What's going on here?"
That would be huge.
And so there were some things that we had to flag.
Okay.
But for the most part, it was pretty good data.
They might have to refund some property taxes.
They might have to refund some property taxes. Yeah, based on the outcome of this.
Cool. So
Yeah.
What's the data that's contributing to this map?
Yeah, sure. So maybe go full screen. So what you're seeing right now are the tax parcels in Denver. And every single little area represents one tax parcel, and there might be more than one building on it. And so the different colors are showing the energy intensity in kilowatts per 1,000 parcel square feet. So not building square feet, but parcel square foot. So like this darkest blob on this map here basically indicates there might be a bunch of buildings there, really high energy loads. So this is showing if Denver fully electrifies using air source heat pumps, which are, I think, the most kind of commercially used and like readily available right now. This might be the future map of energy load in Denver. And I have these numbers on the side here. So all of this load could sum to about like 6.2 gigawatts, which is huge. Denver's current summer peak load is like 1.7, 1.8.
Wow.
Yeah.
How long do you think it could take to get there?
Really good question. And one that we did not really address in this analysis.
Okay.
The adoption rate piece wasn't super in the scope. I think it's going to depend. 2040, 2045, 2050.
Yeah, a long time.
A long time. I mean, yeah.
Yeah.
Considering. Yeah. And then these maps might look really similar, and they indeed are. But this is showing what happens when we do those kind of energy efficiency measures. And so in this analysis, we assumed like a downtown geothermal network loop. And this is because the utility there, Excel, actually has like a small pilot
Okay.
in one of the areas of the city. And our client wanted to know, well, what happens if we assume that pilot could be extended and cover a bunch of the downtown? So that was kind of a cool question. And then we took some other reductions for the surrounding parts of Denver. So the difference between these two scenarios is pretty significant. It's 1.5 gigawatts, which I think really underscores how important efficient electrification is. This scenario also assumes a small penetration of ground source heat pumps,
Okay.
as opposed to just air source heat pumps.
So you mentioned earlier that this method was a kind of bottom up as opposed to top down. So you have the details that we can see in the maps. And what's the advantage of that? Is it that you get a more accurate answer, or that you can do scenarios, or that you can do? I would hope somebody's going to do distribution system planning based on this. But they kind of
Yes, they are. Yes, everything you said.
Oh, good.
So it is more exact because if we're like zooming in on this little area down here, right? We can really tell on a fine level because we're modeling every single building in this neighborhood, what the load is going to be there. The next part of this analysis, and we have some project partners we're working with, is they are doing the distribution. They're doing substation planning, and they are using power flow analysis to actually estimate where the locations of future substations might need to be in Denver to handle this load.
That's
and
great.
I think that if you were doing a top-down analysis, that might be a harder thing to do because you're not working with such fine and exact data.
That's really cool. So I want to get to Massachusetts, but if you wanted people to walk away with one nugget from Denver, what would that be?
I think every city and town in the country who's seriously considering building electrification could do this analysis and should do this analysis. And I think the underlying data is really important. And so preparing good building level tax data is a step that all city planners could take. ahead of analysis like this.
Okay. And would something like Boston's BERDO help, an ordinance that collects information about building energy use, that could help this
Yes.
as well?
Absolutely. Yes, that could be used as great benchmarks, which was a part of this analysis we did, was try to benchmark our current loads against other loads that we knew existed.
Okay, cool.
So this is all about electricity. But meanwhile, the buildings currently are probably using natural gas for heating.
Mostly.
And so I'd imagine this is another 5,000, 6,000 megawatts of electricity in Denver. But would there be, for these same scenarios, would there be a gas reduction? And shouldn't there be a gas map so that we could plan the gas system right sizing?
Interesting question. Yeah. So this is, to clarify, this is total building load, not the incremental load if you for the electrified. Yeah, I think that would be a great follow-on analysis, is looking at what we need in the gas system. And I think to get to your point about when is this going to happen by, the adoption rates weren't part of the analysis, but you could imagine doing some sort of geospatial adoption rate thing where you were saying this region is going to electrify first, and therefore this is what we need on the gas system side. And that could be a cool kind of follow on. Yeah.
Really cool.
So switching gears a little bit, the reason why I wanted to talk about Massachusetts is because not only can you do this sort of cool geospatial load stuff with buildings, you can also do it with electric vehicles. And so we were hired by the Massachusetts Executive Office of Energy and Environmental Affairs, EEA, to basically figure out if we meet our future climate goals in Massachusetts, which have goals for EV adoption, where on the distribution system will we be seeing the most overloading happen.
Okay.
Yeah.
So you had to know about where EVs would be adopted, and then the condition of the grid, or the state of the grid. Okay.
Yeah.
So how'd you approach that analysis?
Yeah. So we worked with two fantastic subcontractors who did travel demand modeling.
Okay.
So they were taking into account things like multifamily housing, long distance travel, locations of population growth, locations of more job growth, all sorts of factors that would impact where people driving and living and charging and using EVs. And I was mentioning that like top down, bottom up approach before, and they sort of did the same thing where they said, okay, we know like the characteristics of all of these places in Massachusetts, and we know we need to hit 900,000 EVs by 2030. Where do we think those EVs are most likely to kind of materialize and also drive and charge?
Who were those subcontractors, and would Synapse work with them again?
Yeah, they were CSE, Center for Sustainable Energy, and RSG. We hope to work with them again because they were great. CSE did like the light duty travel demand modeling, and RSG did the medium and heavy duty vehicle stuff.
Does that include like 18-wheelers and things? Okay.
Yeah, it does. And so what they gave us from their work was basically a map that looks like this, but instead of this being load per tiny little dot here, it was number of chargers per tiny little dot.
Okay.
And it wasn't just number of chargers, it was number of home level 1 chargers, home level 2, public, the whole slew of different charger types.
Okay. Can you tell us about the title of this slide, S2 hex cell energy loads?
Yes, totally.
Okay.
So we had 4 scenarios in this analysis because we wanted to kind of understand what would be the range of impacts in Massachusetts if you could manage some of that charging. So our first scenario was totally unmanaged charging, which meant that people, as soon as they plug in, no matter what type of vehicle you have, your vehicle is going to charge. On the other side, we had scenario 4, which was if you could basically perfectly manage all of the flexible load, what would be the impacts to the system? And so shifting that load so you're charging during kind of off-peak hours. Scenario 2 and 3 were like variations of that. Scenario 2 was this kind of flat load, as steady and low as possible charging profile. And scenario 3 was like the status quo, which we modeled based off of existing managed charging programs that some of the utilities had.
Okay.
Yeah.
Do you know about EV technology, like, is it changing toward having that optimized charging built in, or is it something that has to be managed by the charger?
Yeah. So I'm not an expert
It's
in
okay
that.
if you don't have
My understanding is it can be either or. So for like home charging, if you have like a smart meter that's hooked up to the grid and hooked up to your electric meter in some way, and you're participating in a utility program, they could determine how fast your EV charges. Like the kind of lowest cost is you determine by literally unplugging and plugging your EV.
Yeah. Okay.
I think for the more public chargers and workplace chargers, those would be like managed by the utility via some smart device.
Okay.
Yeah.
Very cool.
Let me go to actually scenario 1, because I think this is like worst case, what it could be. So darker colors show higher load. So you can see these hex cells that you're seeing are like 0.35 square miles.
0.35.
So
Okay.
really, really fine
Yeah,
granularity.
tiny.
And I think that was a cool part of this analysis.
Yeah.
Is similar to the Denver stuff. We were working on like, could see it only with a magnifying glass,
Yeah.
like resolution, which again, I think is cool in this type of work. So
Wait, and there's more than 1,000 chargers in those little spaces?
sorry, this is load. So this is 1,000 kilowatts.
Oh,
Yeah.
okay.
Yeah. But the densest areas, so like the downtown Boston financial area where we're seeing a ton of residential chargers and public chargers, I think the cell with the maximum number of chargers was like 700.
Wow.
Yeah.
In a 0.35 square mile area. Whew.
So are these scenarios all the same amount of, say, like EV driving? It's just different. So it's adoption of EVs and how much people are using them. And this is all about, this 4 scenarios are about how flexible the charging is.
Right. Yes, exactly. So I'll just pan through these 4 figures real quick, and your eye will kind of pick up where the changes are.
Yeah, that scenario 4 is kind of magical thinking probably, but still it has a huge impact.
Yes. And we refer to this scenario as the technical potential of charging because in reality, it's probably not feasible. But it kind of helps with that bookend
Yeah, it's
analysis.
good to know the limit.
Yeah.
So what is the big...
Well, and also that first scenario may not be feasible given
distribution
constraints on building new distribution infrastructure in dense areas.
Yes. And I'm so glad you said that because I wanted to go to this slide, which is scenario 1, feeder overloading, which is showing if all of that load actually materializes, which feeders do we think will overload? Blue lines on this map are okay in 2035. Pink indicate that they're already overloaded using current utility data. We can talk a little bit about that in a second because it's a little confusing. And then the red indicate that they overload from that new EV load.
Wow.
So Western Mass, where I'm from out here, looks okay for the most part. We see a bit of overloading in Springfield and Greenfield. It's Eastern Mass that some towns, we literally predicted that every single feeder would overload if all of this EV load materializes.
Wow. The choice of red is a really good choice because it really tells the story in full color. So, I mean, and look at Martha's Vineyard. Is that I'm just curious what went into that. And I imagine this is summer, of course, but why does Martha's Vineyard look so full? I mean, it's okay if there's not a clear answer, it's fine.
Yeah. So I only have the answer based on just the data the methods we did for the whole state was the same.
Yeah.
So the method for calculating is this feeder going to overload is we took the utility data. They gave us the current capacity of the feeder. They gave us the current peak load on the feeder. And then we added in our EV load and saw what the new basically capacity fraction was. So this basically indicates that the feeders might be smaller or they're already approaching that 80%. Probably smaller feeders that are approaching that 80%. Down in this area, feeders tend to be a little bit larger, but because you have so much EV load, it's still overloading the system.
Wow.
Yeah. And then I'll just go through to the last figure. You can, doing the same thing, you can see how these colors change. And the last scenario looks way better.
Oh my gosh, so much better.
Yeah.
So what do you think the state is going to do with this information?
So this was a neat project because it was part of this big EV assessment that the legislature is required to do by the 2024 climate bill, well, and before. So they have to do this assessment every 2 to 3 years. And we did one for them 2 years ago. This was like the second iteration. And they are using this to try to hit their climate goals, to help figure out where do we need investment from the utility side, where do we need more chargers. And one of the cool outputs from this analysis was the list of our, top overloading feeders that EEA sent to the utilities and said, you need to look at these because our third-party consultant said these feeders might overload.
Okay, great.
Yeah.
This is really fun, and I love looking at the maps. Is there one thing you wanted people to take away from this analysis? What would it be?
I think a part of this analysis we didn't dive too much into is how do we support EV charger development for environmental justice communities in low-income areas. We dove into it a little bit to the extent we could, but one thing that would be cool to work on and to analyze more was, do we expect EV adoption in some of these lower-income communities, and how can we support that into the future? Yeah.
All right. Well, thanks so much for joining us here.
Yeah, thanks,
Yeah, thanks for having me. This
really
was super
cool.
fun.
Yeah, really nice.
I love maps, so it's great to talk about them.
Yeah.